Hey guys, I'm Dr. Linda Goggin. I'm here with Fluffy, and we're continuing our series on how the body's electric. And there's more to these simple things. Right now we're going to talk about water than one might really think. And in fact, water, it's not just water. It's probably the most overlooked substance in biology, and it's one of the most important as well. We tend to think of water as simply what we drink to stay hydrated. H2O, it's a solvent, it dissolves things, right? When you were little, you used to drink bug juice. It was a bunch of sugar and water. But in biology, water behaves not just as a background substance, it actually can carry charge. It can behave differently near charged surfaces, and it can respond to light. So these properties are more important to our physiology than we've ever understood. And there's a lot of interesting new research that's going on around water in the body because you know what? Your body, it's mostly water. It's 60 to 70% water is the oft quoted number. And that number can be a little bit misleading because it's not like we're sloshing around with water, right? It's interacting constantly with proteins and membranes and structural elements that are within the cells. And when it is bumping up against a surface, it behaves differently. Understanding that when water comes into contact with hydrophilic surfaces like proteins, cell membranes, it will form more ordered layers. And we've understand this idea for a while in physical chemistry. It's been explored in biological contexts by smart people like Dr. Gerald Pollack down at the University of Washington and others, that instead of being randomly like just water molecules bumping off of each other, that near those surfaces, water molecules are structured. And Dr. Pollack's group, he wrote a really great book called The Fourth Phase of Water that I highly suggest, and also a book called Cells, Gels, and the Engines of Life, which describe that gel, kind of like a gel form of water that occurs spontaneously next to those charged surfaces. And his work proposed that there's a fourth phase of water, and that's distinct from the other phases that we think about. We already are. Water can be a solid, right? Ice. It can be a liquid. That's what we drink. It can be a gas, steam, but maybe it has this other gel form that is manifests as something called the exclusion zone. Okay, so the exclusion zone describes a portion of structured water that excludes solutes and particles. So the water molecules within that are arranged differently because they're next to these hydrophilic surfaces, and biological surfaces are often hydrophilic surfaces. Cell membranes, collagen fibers, protein structures, virtually all over your body. And it doesn't mean that all the water in the body is in this state, but it suggests that they're playing some kind of a role in what's happening at these interfaces, probably with cell signaling and that sort of thing. Because now we've seen, it takes some pretty specialized equipment to be able to measure something as small as a couple angstroms. It's very, very small. But the idea that the water is structured differently, well, was theoretical until somebody in 2024 at Columbia University. There's a landmark study where researchers published this in Nature Communications, a very reputable journal, showing that with Raman microspectroscopy, it's a way of measuring light emitted by cells and structures. They could almost look inside the cell and say, hey, what's going in here? Is this like water in a glass? And the answer was no. 3% of the water within cells, which is small, but it was consistent across different cells, was found to be structurally distinct. It showed a weakened hydrogen bonded network and more like a tetrahedral structure. And they called this bio-interfacial water. And it sits up against the surfaces of biomolecules. And, when they were looking at whole cell modeling, they showed that every single soluble protein in the cell, on average, is surrounded by a full molecular layer of structurally altered water. And so it's really small, but they were able to show this. And this was repeated across several different cell types, um, immune macrophages, neurons, and HeLa cells. And they looked at more than 100 different cells. And the signature was kind of the same through them all. I think the next question is, how does this matter for us, right? Does it matter if it's only 3% of this water in the cell? Well, the concentration kind of tells you a different story. So if there's 1.5 moles of bio-interfacial water, this is more concentrated than the most abundant electrolyte in the cell, potassium. That's around zero point 0.1 molar. And so this is not just a tiny little thing. It is a major chemical presence that's changing what's happening. Right, Fluffy? Right, major, major issue. The location is everything, right? The fact that it's sitting, not just passively hanging out in the middle of the cell, it's wrapping around all the proteins. It's probably affecting signaling that's happening as things are moving across membranes, and every structural molecule in your cells is operating beneath a special layer of water that's not just plain old bulk water. It's going to affect how the proteins fold and wrap around each other, and protein folding in turn affects how enzymes function. It depends how well you're making the things you need to make your body work right. Okay, the fact that it's the same across different cell types suggests that this has probably evolved to be this way. It's not just random, right? And life's found a way to maintain this very special water environment around its proteins. And practically, the osmotic changes, like when you haven't had a lot of water, or you are well hydrated after drinking a whole bunch of water, well, this is going to influence the molecular environment that your proteins are working in. These ideas are still in their infancy, right? We're just starting to get this. And this is what's going to open doors, giving ideas for experiments. How can we really figure out what's happening within the body? So understanding that structured water is not the same as ordinary water is really important. The structured water appears to carry a net negative charge, and protons are kicked out, making a separation of charge. And you know what? A charge gradient, a separation of charge between different areas, well, that actually creates a battery, right? So, what if part of this was the battery effect? And still, like I say, this is speculation, but it's very interesting because we know that our body is making energy. We talked before about our body is making light, and the charge separation is like you're storing energy in that water layer. And uh, what we want is for our body to have as much energy as possible. That's the number one thing that people come to see me for, my clinic, is energy, I'd say. Interestingly, in the laboratory, when you look at this water, light, when shown on the water that's coming up against a charged surface, light will make the exclusion zone grow. It adds to the padding. And I think that when we can measurably influence the exclusion zone, the question is that going to be helpful to the body? We know that the body is somehow making light. Well, where's that coming from? But it just creates these new questions, like, how does sunlight truly affect us? What if we were able to, and we're already using light externally, what if we could use light internally? Would that be helpful for our bodily systems? We know that water is kind of a cellular organizer. That it influences, like, the enzymes, proteins, and it may be that this gel-like quality of intracellular water that Pollock described is going to help us understand more and more how you work and start to rethink hydration. we used to think of just how much you're drinking, right? How much water we drink. But if water exists in different structural states, it may be that the structure of the water is going to be important as you're trying to hydrate. Another thing I want you to start to think about is this water is the idea of water as a signal medium, right? If water carries charge and it can respond to light, it just raises this natural question: could water act as a medium for light related processes in biology? At this point, this is a hypothesis, but it's a reasonable question to explore. And when we think of adding light to the body, and generally, it's a pretty safe thing to be doing. And the more we understand about how light and water interact, the more we'll be able to apply it for health and wellness. So I want you to just think about it. Give this a little bit of thought. I hope this has been something that makes you go to PubMed. There are some interesting papers that have been published just in the past couple of years about how the body is structured. And finally, what I want to do is I want to play a quick video for you. Let's see if I can find a way to play this video. Let me see if I can pull it up. A video. Yes. All right. This is called Unwinding the Heart Center. And this video is showing how the heart is a vortex. Okay.
To my mind, the human heart center is not a pump. It's a spinner.
Hey, I'm going to pause it for just a second before you watch this. And so this is going to show within it a human heart that's been dissected that he holds in his hands. In case you're triggered, I just want to make sure I warn you. And the reason I'm showing you this is because one way that you can make this type of structured water is by putting water through a vortex. And I want you to think about the fact that every time blood runs through your heart, it is running through a vortex that may be intentionally made that way to energize the water. Okay, so here it comes. This is really, really beautiful. And it makes me smell formaldehyde when I listen to it, because of the last time that I saw a human heart like this was in my medical school when we were learning about how all the inner workings of the body, and there was a lot of formaldehyde involved in that.
It's a blood spinner, and its shape kind of proves it. So come on down here and have a look just at this towel. If I have a towel, right, and I kind of have it, say I fold it up, this little thing. Now look, it kind of starts out this way, but if a vortex were to go through it, that would make it spin, right? And spin, and we kind of turn it on itself. We just keep spinning, and look what happens to materials and fluids that are spinning. They start to braid around each other, and we end up with a shape something like that. Okay, now enter the human heart. I highly recommend it. We have a beautiful heart center here from our donor Z, who's given us many gifts. We have our right ventricle and our left ventricle, and I want to show you in reverse how the heart demonstrates that same sort of braiding and turning upon itself. So we have our sort of like a conch shell with the most inner turn and the most outer turn here, the right ventricle and the left ventricle. And if I've already done this, but you see that beautiful spiral? See how the upper vasculature of the heart, the pulmonary trunk and the aorta, are turned around each other. And as I draw them apart, of course I dissected this, we see now in my right hand I have the right ventricle, and in my left hand I have the left, and I'm unwinding the wall between them. And can you see this incredible conch shell as it unwinds? Look at this. Look at the beautiful fiber direction as we proceed further and further until I'm in the chamber, and the chamber itself is wound upon itself, the left ventricle here. And if I had more hands, look at this, see? It really, if I keep on holding the shape, you see, I can then reach out to the right side and unwind it as well. And we end up with a vortex, a hurricane that's turned upon itself, right? So there's our towel. Here's our towel, and then we wind up the towel on itself. And it rolls and rolls until we see the familiar form of our beautiful heart center. But now we know one little inner secret about it, right? We know that our heart is really the locus where the blood spins itself, right? The life force is refreshed and spun by the contraction of the fibers of the beautiful heart center, literally wringing the blood out of itself as it ejects through these incredible valves and tours the entire human form before it returns again for another refreshing wringing out and spinning forth the re-oxygenated blood. Incredible, huh? Look at that. Wow.
So I think that gives you a sense of where we're going here, understanding the body as a generator of energy, a mover of charge. You are created by mostly water. Charges within the body are what are driving biological systems, and our body is even made so that it is created with vortices, like the vortex of your heart, which is basically spinning that blood out and giving you energy. So join me with the next video, where you're going to learn more about water, light, energy, and the body. All right, you guys have an awesome day. Thank you so much for joining me and Fluffy. All right, take care.